Hello, Titans. I want to spend a little bit of time going through some relationships, graphing relationships with you. We as physicists, our job is to understand this universe of ours. And one way we do that is by collecting data through a lab and graphing those data. And we'll see what kind of graphs we come up with. It turns out almost all those relationships are going to fall into one of 5 categories. And I'd like you to understand what those things are. You should have access to a note sheet that lists basically what I have on the board here. I'd like you to take those notes and refer to them often this year. So 5 relationships we're going to run into. First one is just a flat line, y and x, and we have a horizontal line. The shape is a horizontal line. Nothing fancy about that. Relationship? Well, there's no relationship. No matter what the x is, or excuse me, no matter what the y is, I'm saying this wrong. No matter what the x is, the y stays constant. So there's no relationship there. The equation? Well, y has nothing to do with x, so we just say y equals a. No matter what the x is, the y is always the same. So it's just a constant in this case. We don't see that all that often. Although if we do see it, it just means, hey, x and y aren't related. These 2 variables that we've investigated are not related at all. And that's okay. Second type of equation we're going to run into, or second type of graph we're going to run into, is a line. Shape is a line. The relationship is linear. And you all know the equation for a line. You've seen that in math class over and over and over again. That equation simply says y equals mx plus b, m being your slope, b being your y-intercept. So these first 2, pretty basic. Nothing real fancy about this. You've seen it before. And we see it in physics often. The third type we're going to run into is a little weirder. This one's a curve. So it looks like as y is a big value, x is a small value, and vice versa. So these 2 are, we say, inversely related. In fact, the shape of that, we call it hyperbola. You've probably seen that in math class. The relationship, we say, is an inverse. In other words, one goes up, the other goes down. As x gets bigger, y gets smaller, and vice versa. The equation, well, in fact, our equation is going to say y equals m. Instead of x, since one goes up and the other goes down, they're inversely related. The inverse is a reciprocal. So we're going to say y equals m times 1 over x plus b. The problem is we don't like curved lines. We don't analyze those so well. So what we try and do is linearize it. So when to do something to linearize the graph, we're going to want to make it to come out to be a straight line. So how do we do that? Well, since the x is flipped, basically, y gets bigger, x gets smaller, what we can do is simply graph this part. Leave the m alone, leave the b alone, but y is related to 1 over x. So if y equals 1 over x, we get a relationship this way. In other words, we're graphing y versus 1 over x. So what does that mean for you? Well, if you make a graph like this, you say, oh, that's an inverse relationship. What do I do now? Well, you're going to make a new graph. Your new graph, well, the same y, but you will flip each of the x's. You'll take its reciprocal, plot those, and you're going to find out a miracle happens that we get a straight line. Try it. You'll see. And we will be trying this in the next week. The fourth relationship we're going to run into is a line that curves up like that. Well, you've seen that kind of a graph before, I think, in math class. We call that a parabola. Incidentally, we never call them type 1, type 2, type 3, type 4, and type 5. We just call them by what they are, as a parabolic graph. The relationship is a quadratic relationship. You know that. Quadratic relationships are your favorites. You know from math class that quadratic relationships produce parabolas when you graph them. The equation, y equals mx squared plus b. And finally, we're going to do the same thing. When we look at this graph, we say, okay, that's nice. It's a pretty line, but we like to deal with straight lines, don't we? Straight lines are a lot easier for us to analyze. So what we're going to do now is we're going to look at this and we're going to say, all right, how do I linearize that? Well, we're going to do the same thing. We're going to say y, and then the x squared is related to y. So I can write y equals x squared, and that's going to give me a graph. That's a straight line. So if I graph y versus x squared, I'm going to come up with a straight line. Again, we'll try it out in the next week or so, and you're going to see, I think, that that's true. So if you get a graph like this, and you see a parabolic relationship, simply square your x-axis, graph it again, you'll find yourself with a linear graph. Finally, the last one, type 5. This is a little weird. Maybe I think some of you have seen this also in math class. The shape is a square root graph, called a root graph. The relationship is a square root. That's not a math term necessarily in terms of things like parabolas and hyperbolas. We don't say root graph is a mathematical shape, but that's okay. Equation, what do we do with that? Well, as it is a square root, we can graph y equals m times the square root of x plus b. But that's a little weird. That's a little awkward, and it's not real convenient to square root the x. So we could graph y versus the square root of x, and that would still work when we linearize it, but it's probably easier to do y squared equals mx plus b. In practice, it's a lot easier to square your y, leave your x alone. And when we do that, we've got a y squared versus x. Again, we'll get a linear graph. Of course, you could do the same thing I wrote up here. You could graph y versus square root of x. You get the same graph, but that's how we're going to linearize what I'll call a type 5 graph. All right, so I hope you have your notes down from this little lecture, and you will refer to those over and over and over again. I know, but hopefully you'll have these committed to memory before too long, but if you don't, you'll always know where you have access to these notes. Thank you for listening. Have a great day.